This video program contains following chapter: 1. Disassembly, 2. Adjustments, 3. Operational flowchart, 4. Self-diagnosis and error display. In Chapter 1, Disassembly, Section 1, Set up Service Condition 1. In this section, you will see how to set up the headboard assay to the service condition. First, remove the screw on the right side of the front panel. Then, the screw on the headphone assembly. Then remove the 3 screws on the bottom of the front panel. Pull the tray out and pull the right side of the front panel towards front side so that you can remove the screws that fix the headboard assembly. Do not pull the front panel too strong, else you may break the left side of the front panel which is fixed to the chassis. After removing the 4 screws of the headboard assembly, set the cables free from the cord holders. Place the headboard assembly upright against the slit of the float base. There are slits on the front side and back side of the float base. And you can diagnose headboard assembly in this condition. In this section, you'll see how to set up the servo microcomputer board assembly to the service condition. First, you must remove audio digital board assembly with rear base. Set the cables free from the cord holders. Then remove 3 screws from the rear panel. And 1 on the side, and 1 attached to the bottom chassis. To remove the sub microcomputer board assembly, first remove 3 screws on the board, then 1 PCB holder and headphone cable. Pull up the sub microcomputer board assembly and put the edge of the board into the slit of the front panel. You can diagnose sub-microcomputer board in this condition. In this section, you will see how to remove sub-mechanism assembly. After you have removed headboard assembly, remove the cables from the headboard assembly. Do not touch the end of pickup flexible cable with your finger, else you may break the pickup. Remove 4 screws which fixes the serve mechanism to the float base. Then loosen the screw which fixes the clamp spring. And you can take out serve mechanism. In this section, you will see how to disassemble and assemble mechanism assembly. First, you will see how to remove the tray. Pull the tray out and remove the front panel. Then push the hook on the both sides of the loading base and pull the tray. Push the hook down and remove the tray. Now you will see how to remove mechanism assembly. Mechanism assembly is fixed to the chassis by 5 screws. Remove these 5 screws. Then remove the screw that fixes the ground cable. Now disconnect cables and remove mechanism assembly. Now you will see how to assemble the mechanism assembly. Mechanism assembly consists of 4 main parts: left and right cam, floating base with sub-mechanism assembly, and loading base. There are signs on each cam that indicates position of each cam. Now we will assemble float base and 2 cams. The boss on the right side of the float base should go into the slit of the right cam. And the left boss should go into the slit of the left cam. Then move the right cam towards front side and left cam towards back side. Attach the cam and float base to the loading base. Make sure that the tip of the cam is inserted to the slit of the timing lever. Here you will see how the cam is attached to the loading base. The both of the loading base should go into the slit of the cam, and the tip of the cam should be inserted to the slit of the timing lever. Now you will see how to insert the tray. Before inserting the tray, you must adjust position of the drive gear and timing lever. After adjusting the position of the drive gear and timing lever, insert the tray and check the movement of loading and clamping. Chapter 2: Adjustments. Preparations and test mode. These are the measuring instruments and tools. 2 discs are needed to carry out the adjustment: STD903 and STD-R03. Measuring instruments needed are low-frequency oscillator and dual-trace oscilloscope. Adjustment value of the laser power are written on the flexible cable of the pickup. To enter the test mode, you must short the test mode points on the servo microcomputer board assembly. Short the test mode points and plug in the AC plug. If the unit is set into the test mode correctly, all the segments of the FL display will be written. Now you will see operations of the keys in the test mode. To light up the laser diode by playback power, press digital synchro key. To light up the laser diode and get focus servo closed, press finalize key. To close the spindle servo, press play key. To close and open tracking servo, press pause key. To move the pickup inward, press search reverse key. To move the pickup outwards, press search forward key. And to get tracking servo on again, press pause key. Press stop to stop and open to open the tray. To switch the focus offset, press display key. To switch optical axis servo, press right key. To light up the laser diode with recording power, press record key and rec mute key. Adjustment order. Adjustment procedure is separated into 2 sections. Adjustment 1 is mainly servo mechanism adjustment, Adjustment 2 is mainly electrical adjustment. When servo mechanism or pickup is replaced, Adjustment 1 and Adjustment 2 must be done. When a board assay is replaced, it is enough to carry out only Adjustment 2. Some of the adjustments are same as usual CD player adjustment, and 12 adjustments that are indicated in red color are the adjustments only for CDR. These 12 adjustments are explained in section 2.4. Test points and adjustment locations. There is TP1 on the headboard assembly that is used for the measuring point during adjustment. You will find almost all the variable registers that are needed for the adjustments on this board. There is TP201 and TP00 on the servo microcomputer board assembly that are used for the measuring point. There is VL201 focus gain adjustments and VL202 tracking error gain adjustment on this board. There is mechanical adjustment point on the servo mechanism, tangential skew adjustment screw, radial screw adjustment screw, grating adjustment slit. Connections and waveform. As explained in section 2.2, here in this section, you will only see the adjustment indicated in red colors. These adjustments are characteristic adjustments of CDR. Playback laser power adjustment. Connect oscilloscope to TP1 pin 7 of headboard assembly. Press digital synchro key to light up the laser diode with playback power. Turn VL103 to adjust the power of the laser diode. The adjustment value is indicated on the pickup flexible cable. Turn VL103 and adjust to the indicated value. Note that this value differs in each pickup. Wobble plus offset adjustment. Connect oscilloscope to the TP1 pin 6 of headboard assembly. Press stop key to set the unit into stop mode. Turn VL107 to adjust the wobble plus offset. Before adjusting VL107, turn VL108 to fully counterclockwise. Then adjust VL107 so that DC voltage at TP1 pin 6 is minus 20 mV plus minus 10 mV. Wobble offset adjustment. Connect oscilloscope to TP1 pin 5 of headboard assembly. Press stop key to set the unit into stop mode. Turn VL8 to adjust the wobble offset. Adjust VL108 so that the voltage at TP1 pin 5 becomes 0 volt plus minus 10 mV. Main and sub tracking error mix ratio adjustment. Connect channel 1 of the oscilloscope to TP1 pin 1. Connect channel 2 of the oscilloscope to TP1 pin 2. Note that in this adjustment, the range of channel 2 must be double the range of channel 1. Press finalize key to close the focus servo. Press play key to run the spindle motor. Keep the tracking servo loop open. Then turn VL110 to adjust the mix ratio. Adjust BR110 so that the amplitude of the waveform becomes minimum. Tracking amp gain adjustment. Connect oscilloscope to TP1 pin 3 via low-pass filter. Press finalize key to close the focus servo. Press play key to run the spindle motor. Keep the tracking servo loop open. Turn BR111 to adjust the tracking error amp gain. Adjust BR111 so that the amplitude of the tracking error signal is 1 volt plus minus 0.05 volt. Actuator offset adjustment. Connect oscilloscope to TP00 pin 1 of sub-microcomputer board assembly. Press finalize key to close the focus servo. Press play key to run the spindle motor. Then move the pickup to midway across the disc with track search key. Keep the tracking servo loop open. Turn BR1 at headboard assembly to adjust the actuator offset. Adjust BR1 so that the DC voltage at TP00 pin 1 is 0 plus minus 20 mV. Actuator gain adjustment. In the same condition as actuator offset adjustment, turn VR10 at headboard assembly to adjust actuator gain. Adjust VR10 so that the DC voltage is minus 380 plus minus 20 mV. Wobble balance adjustment. Connect oscilloscope to TP1 pin 5 of headboard assembly via high-pass filter. Set test disk STDR03 on the unit. Press finalize key to close the focus servo. Press play key to run the spindle motor. Move the pickup to midway across the disc with track search key. Press pause key to close the tracking servo. Then turn VR106 to adjust the wobble balance. Adjust VR106 so that the amplitude of the waveform is minimum. Fine wobble offset adjustment. In the same condition as wobble balance adjustment, turn VR108 to adjust wobble offset. Adjust VR108 so that the waveform is minimum. Wobble focus offset adjustment. Set the unit in the same condition as done in wobble offset adjustment. Press display key to light up the display off key LED. Turn VR115 and adjust wobble focus offset. Adjust VR115 so that the amplitude of the waveform is minimum. Recording power adjustment. Connect oscilloscope to TP1 pin 7 of headboard assembly. Take out the disc from the unit. Turn VR104 fully counterclockwise to reduce the power to the minimum. Press REC and REC mute key to light up the laser diode. Turn VR104 slowly clockwise to adjust the recording power. Adjustment value of the laser power is indicated on the flexible cable of the pickup. Adjust VR104 so that the voltage becomes the indicated value. HF amp gain adjustment. Connect oscilloscope to TP1 pin 8 of headboard assembly. Set test disk STD903. Press finalize key to close the focus servo. Press play key to run the spindle motor. Then move the pickup towards midway across the disk with search key. Press pause key to close the tracking servo. Turn BR119 to adjust the HF amp gain. Adjust BR119 so that the amplitude of the waveform is 2 volt plus minus 0.1 volt. Chapter 3 Operational Flowchart. Here in this chapter, you see CDR disk format, power on, stop to recording, stop to open operational flowchart, and block diagram explanation. CDR disk format. This is CDR disk format. There is table of contents area here. This area exists in the same place as in normal CD. TOC is recorded only when the disk is to be finalized. This area is called program memory area and exists inside the TOC area. This is temporary TOC that is recorded when the disk is partially recorded. This is called power calibration area. To obtain the optimum recording power, the unit calibrates its recording laser power for each disk. Test recording and calibration is done in this area. This is program area, and audio signal is recorded in this part of the disk. Power on sequence. When the AC plug is plugged in, the unit first checks the battery by confirming the checksum of the RAM. If the battery is OK, the unit confirms the backup data in the RAM. If TOC data exists, the disk exists, so the unit moves on to stop mode. Stops the servo, stops the spindle, and pickup moves to the TOC area, and the unit stops. If the backup data does not exist, the unit moves on to setup mode. In the setup mode, pickup moves to the TOC area, then tries to get the focus servo on. If the disk does not exist, it stops. Now the disk is inserted. In the setup mode, the pickup moves to the TOC area. Then, this time it gets the focus at TOC area. Then the spindle motor starts to run with CAV servo, and disk type is detected by detecting the pits in the TOC area. If the pits exist in TOC area, the disk is either CD or finalized CDR disk. If not, the disk is recordable CDR disk. Tracking gain adjustment is done automatically according to the type of disk. Then tracking servo is closed. Next, the spindle servo is closed, but according to the disk, different spindle servo control is applied. For CD, spindle EFM servo is applied, and for CDR, spindle wobble servo is applied. Now the unit reads the data in the talk area. For CD, TOC data is read, and for CDR, ATIP special information is read. If the disk is not CDR, That means if the disk is CD or finalized CDR, pickup moves to the 0 position of the absolute time. Then the disk rotation is measured, and if the play key was pressed, it plays the disk, and if not, it stops. If the disk is CDR, first the unit searches for the PMA area, and PMA data is read. Then searches for the 0 position of the absolute time, and disk rotation is measured. Stop the recording sequence. When the recording key is pressed, the unit goes into the setup mode. Focus servo closed, spindle run, and tracking servo closed. Then it moves on to recording power calibration. This OPC is done only once after a CDR disk is mounted. So if OPC was already done on the mounted disk, it skips the OPC and moves on to the next state. If not, then the unit performs the OPC. In the OPC mode, the pickup moves to the PCA area, then it performs the test recording by changing its recording power by 15 steps. Then play back the area just recorded and determines the optimum recording power according to the playback result. Then the pickup moves to the end of the recorded section and waits in the recording pause mode until rec key is pressed. When the rec key is pressed, the unit moves on to the actual recording mode. In the recording mode, it sets EFM encoder and servo circuits to recording mode, then starts recording. Until the rec key is pressed, the pickup keeps on one-track reverse jump and stays in the rec pause mode. Stop to open sequence. When the open key is pressed, the unit first determines the type of the mounted disk by reading the data in the RAM. If the mounted disk was CDR, the unit determines if the recording was performed on the disk. If the recording was performed on the disk, PMA, which is temporary TOC, must be recorded on the PMA area of the disk. The unit moves on to the PMA recording mode. It organizes the data in the RAM that is to be recorded on the PMA. Pickup moves to the end of the recorded section in the PMA area. Then PMA data is recorded on the PMA area. Then it stops and ejects the tray. If the mounted disk was CD, then it ejects the tray immediately. And also, if the disk was CDR, but no recording was done on that disk, then again, it ejects the tray immediately. Block diagram explanation. In this section, you will see the block diagram explanation. A very different section from the normal CD player is, as you know, that it has an input and recording function. In this block diagram, the block can be divided into mainly 4 sections. This is audio input section, and this is audio output section. This is servo control section, and this is control section. Here will be the explanation for main ICs. This is EFM encoder, and it has following functions: EFM encode, input and output selection, digital interface modulation and demodulation, fader and level detection. This is FSC IC. It converts the sampling frequency of the input digital signal to 44.1 kHz sampling frequency. This is 3-sec delay memory. The unit needs about 3 seconds to detect copy protect code in the digital signal input. Therefore, the input signal is delayed in the RAM while detection of the code is taking place. And if the input signal was protected, then the unit cannot record the signal. This is EFM decoder, which is same as the one used in the normal CD player. And this is servo control IC, and then also this is same as the one used in the normal CD player. This is RF amp IC. It has recording laser power control function and RF sampling hold function in addition to normal CD's RF amp IC function. This is CDR servo amp IC, and it has following function: spindle control selection, mirror signal detection, RF level detection, RF detection, tracking error gain selection, and decoding power selection. This is ATIP decoder IC. It has ATIP decode function, wobble spindle motor control function, loading drive output function, and decoding power DA function. This is mode control CPU, which mainly controls FL display and key inputs. And this is mechanism control CPU. Now you will see how the audio signal flows during playback of CD or CDR disc. The RF signal is detected at photodetector, and it is amplified in RF amp IC. Then it is input to servo control IC. The RF is comparated in the IC and input to EFM decoder as EFM signal. Audio data and digital interface format audio data is input to EFM encoder. Digital interface format audio data is output to the digital output, and audio data is input to digital filter, then to DA converter, and output as analog audio signal. Now you will see the servo control during playback of normal CD or final CDR disc. In this case, it is almost the same as the servo control in the normal CD player. Signals detected by 8-division photodiode are input to RF amp IC, and focus tracking error signal is generated in the IC. The error signal is then input to servo control IC, and focus tracking slider drive signal is output from the IC and controls the focus and tracking coil and slider motor. In the EFM decoder, the sync signal rate of EFM signal is compared with master clock, and spindle motor is derived by the error signal between sync signal and master clock via CDR servo amp IC. Now you will see the audio signal flow during recording mode. The analog audio input goes through recording level and recording balance adjustment block. then converted to digital signal and input to EFM encoder. It is then once stored in the 3-sec delay memory and input back to EFM encoder to encode audio signal to EFM signal. Rec EFM signal is output from EFM encoder, and by this signal, laser power is switched alternatively from rec power to non-recording power, and EFM is recorded on the disk as bit. On recording of digital signal, the digital signal is once input to EFM encoder and then output to FS converter IC. Here, the sampling frequency is converted to 44.1 kHz and then input to the EFM encoder again. The rest is same as the analog audio recording. In recording mode or recording pause mode, the input signal is also output to analog output and digital output through EFM encoder. Now you will see the servo control during recording mode. The signals detected at 8 division photodiode is input to RF amp IC. The level of the signal is changing alternatively as the laser power changes. In the sampling hold circuit of this IC, the signal at low laser power is extracted and error signal is generated. Error signal is then input to servo control IC, and focus tracking slider is derived by the signal. The spindle servo is controlled by wobble servo during recording. The wobble signal is generated at RF amp IC, and then it is input to ATIP decoder via CDR servo amp IC. Here in this IC, wobble signal is compared with master clock, and spindle error signal is generated. Also in this IC, absolute time data is decoded from the wobble signal. Spindle error signal is then input to CDR servo control IC and then drives the spindle motor. Chapter 4: Self-diagnosis and error display. This player has self-diagnosis and error display function. When the unit detects abnormal operations of mechanism or circuits, it displays check or check disk and stops. When check is displayed, it is likely that some section of the unit is defect, and if check disk is displayed, it is likely that the disk has scratch or dust on it. When check or check disk is displayed, you can see the error detail by pressing stop key for 10 seconds. Error is displayed in 2 characters, one alphabet that represent defect section, and one number that represent the state of the unit when error has occurred. For example, if the loading motor of the unit is defect, the tray does not draw in even though the open-close key is pressed, and the unit displays check on the FR display. Press stop key for 10 seconds and you will see error code L1. L represent loading section and 1 represent tray open state. And also in the service manual, you'll find what parts to check if the error was displayed.